All right, so we're talking about high level. Well, everybody can hear me first of all, right? Let's go that route. Yep. Okay. So we were talking about high level architecture of ARM-based processors, or at least that's what you were supposed to look into. So specifically, let me know what registers are available, how large they are, maybe pick a recent ARM processor from Apple or the Snapdragon chips for Android. I kind of suggested maybe if you're an Android user, you look into the Snapdragon chips. If you're an iPhone user, you look into the iPhone chips. I think we'll find that there is significant similarity. So what did we find? What points of interest did we find related to the ARM architecture?
I need to know more about how large the registers are.
Okay.
I didn't get it properly.
How large the registers are.
Yeah.
What do you mean by that?
I mean, I got what are the registers and what are the register types, 32 bits registers, but I'm not sure about what's the size, how large they are. I didn't understand it properly.
Okay. Well, so what did we find? So we have multiple registers. We'll start with that so far.
1 minute. So in my assignment, I have mentioned few core registers and the summary, like what's their purpose and all.
Okay.
But I didn't find any information on what is this, how large the registers are. I tried looking for that, but I didn't get any proper information on it.
Okay. Well, we'll get there. So what's the name of some of the registers? Let's focus on what we did find. So what's the name of some of the registers?
I'm considering ARM architecture, ARMv8M, and in this I found few core registers: ROR12, MSP-R13, PSP-R13, MSP-LIM, PSP-LIM, LR-R14, PCR-15, PSR, PRI mask, base PRI, fault mask, control, and these are the registers I've mentioned in it.
Yep. Okay. So there's multiple registers. So we have general purpose registers as well as, let's call them tool specific registers, typically used by jump and flag commands. And we'll probably see some of those just looking at our small examples as we'll look at. Okay, so what else did we find? So we got a bunch of registers that are part of the ARM architecture. This is very similar. So we can say generally very similar to Intel and other CPU architectures. So regardless of what processor architecture we're looking at, we typically have a whole bunch of, you're late. Well, now I do have to figure out how to get this monitor on. This is going to There we go. All right, so, but it's fair to say that a processor is a processor from a hardware register perspective. Registers are like variables built out of hardware that are part of the CPU. All right, what else did we find that was interesting about the ARM architecture? That's it? Nothing else interesting?
I found this thing called trust zone insecurity extinction.
Okay, so tell me more about that.
So it says trust zone is a security extension that provides hardware isolation within the microcontroller, so that developers can create secure and unsecure regions.
Okay, so ARM processors, well, let's see, has a type of hardware-based VM for running applications in a sandbox separate from other applications. So the ultimate goal here would be have the speed of hardware segregation of applications with the benefit of software-based virtual machines like Java / .NET. Well, really, Java's the software-based one. .NET actually just uses the operating system's virtualizer, but software-based virtual machines like Java. So if we think about like an Android operating system running on a virtual device, the Android operating system itself provides, since it's based on top of, well, it's based on top of C and C++, but you develop for it in Java and it creates software-based virtual machines. Those software-based virtual machines can then actually run at the architecture level as separation. So you should get more speed out of your applications. Maybe we just say apps are less sluggish. All right, what else? What differences do we find between the Snapdragon ARM architecture and the iPhone ARM architecture? Apple's A series chips.
I found the minimum difference depending on which version we're talking about. So first of all, I found the latest ARM versions that they both use had 64-bit base, while the previous ones were 32-bit base.
Okay. So latest use 64-bit registers.
And also I found that for the cache memory,
Yeah.
the Android uses all three types of text, L1, L2, and L3, that's the internal and external one, while the iPhone only uses the external layer, L3.
Yep. So Android, well, let's say Snapdragon. Uses L1, L2, L3, where L1 and L2, well, we'll just put that as a separate thing. The AX chips use L3 only for sharing between cores.
Snapdragon 8 core. I'm also talking about the new one.
Yeah, you're talking about the latest, greatest, the current rendition of the architecture. All right, so so if we talk about Snapdragon, you said it has 8 cores. Tell me about those 8 cores.
I explored the iPhone one.
Okay.
I know that we divided into 1 and 3 and 4. So there's 1 separate core, 3 separate cores, 4 separate cores. But I didn't investigate know why they divided it to 1 and 3 and 4. So 1 core that works separately, then 3 cores that work separately, and 4 cores but they're all 8 cores.
Okay. So you mean for Snapdragon?
Yes.
Okay. What about the iOS? 6 cores in iOS.
Yeah, they have 2 cores that they call the high performance
Yep.
core, and 4 cores, they but there's the need to perform tasks.
All right, so on iOS, we have some separation of cores. So there are 6 total cores in the current chip. 2 of them are high performance gaming, stuff like that. The other 4 are efficiency cores that are running at a slower speed, but they're for things like you're checking your email, stuff like that. Things that are not processor intensive, but do still need a processor, right? Where from an end user's perspective, if we're not going to notice a speed difference, or at least not a substantial speed difference, we would probably prefer to have our battery last longer, right? And if we're sitting there playing a video game or something like that for an hour on our phone, kind of our expectation is we might be going through a battery pretty quickly, but that's okay. That was a decision we made, and we want the horsepower behind the scenes so that our game runs well, right? Okay. Anybody investigate the differences in cores on Snapdragon? We got nothing. Nobody online did Snapdragon? Latest greatest Snapdragon processor. Okay, so here were the 3 cores that you mentioned, the 1, 3, and 4. All right, so if we look at the performance of these cores, so we have a Cryo 680 Prime ARM processor, so faster, right? So we have 1 super fast core. Go back to this. Snapdragon has 1 high performance. We have 3, maybe let's call them medium performance. And then we have 4 efficiency. All right, so Snapdragon took a similar approach. Their last several processors have been 8-core processors, actually more than several. I don't know, several can do. What's the maximum number several can be? 4? 3? Maybe 4. Okay, well, so I think maybe even longer than several then. They've had 8-core processors in their Snapdragon chips for a while now, but it's this newer trend to have those cores kind of operate at different performance levels. Only over the last couple of architectures has that started being a thing. Again, as we discussed, as we discussed, battery life is an important aspect to mobile computing, and performance is an important aspect to human beings being happy with the computers that are in their hand. And somewhere we have to have the ability to make those decisions. So what does Snapdragon on Android give us? It gives us 3 different layers, 3 different levels of performance. High battery use, high performance; medium battery use, medium performance; low battery use, low performance, something like that. All right, now notice here, why do you think that the 4 efficiency, why do you think there's only 1 high performance, yet there's 4 efficiency? Let's just look at the extremes.
I think power consumption is one is.
Okay, well, definitely this whole decision is being made based on power consumption, but why specifically is there only 1 high performance core? Notice over in iOS, we have 2 high performance cores, but there's only 1 high performance core in Snapdragon, and we have 4 efficiency cores. Why do you think they made the decision to only have 1 high performance core rather than 2 or more high performance cores, because they have 8 cores to work with. Their architecture supports 8 cores. Now, realistically, they could have put any cores in there they wanted, right? Just said, hey, we're going to have slower battery life. Why do you think they chose to only have one high performance core? What might we use a high performance core for?
Pretty much every application requires you to use like your system to use that high performance core. That's why they have dedicated one for high performance core and the other one for the efficiency in order to take over ultimately their hands.
Okay, so let me ask this question.
It's heavily based on OS, right?
Well, I mean, so let me ask a question. So you're saying it's heavily based on OS. I think that's a true statement. I'm about to ask the question of why have multiple cores at all? What does this allow us to do? What does having multiple cores allow us to accomplish? We'll do more than one thing at a time, right? So this allows us to do more than one thing at a time. Each core gives us the ability to do one. We're going to actually say, we'll say one-ish. I don't know if I can say one-ish. One-ish, can I hyphenate? One-ish task at a time. Some architectures, an individual core has some, and Intel, it's called hyper-threading. They have some ability to sort of kind of do 1.5, 1 2/3 tasks at once because they can preload stuff in the pipeline and kind of pre-start the next task. But so one-ish, I think, kind of covers the idea here across the board. So each core lets us do one thing at a time. So we might say sometimes we might want to actually do more than one thing at one time, at once, let's just say. Now, in real life, well, let's go back a little bit. If we roll back the clock into the early days of computing, and we don't have to go back, really that far before we just had single core processors, did that mean that we can only do one thing at a time on the computer? Technically, if we had one core, we could technically only do one thing at a time. But to the human, did we think more than one thing was happening at once? How did the computer pull that off? If the computer could only technically do one thing at a time, how did we have the ability? I mean, when Windows 95 came out and it had, multitasking, you can have 10 applications open at once. From our perspective, from the end user perspective, we thought all 10 of those things was getting CPU love, right? It was getting a little bit of horsepower, so it would keep running, things like that. How did it accomplish that if it only had one core?
Try to use that one core for all the responsibility for all the tasks.
Okay, so it didn't just try; it had to, right? It had to use. He said it tried to use that one core for all the tasks. Well, it had to. It only had one core, so it had to use that one core for all the tasks. But we were tricked. How? We thought all those things were happening at once. How did it trick us?
It was working on the application we actually use because we aren't using the 10 applications at once. They're open, they're set background, but we're using technically one at a time, so it's working on the application that we use currently.
Okay, so you're saying that the application we had in the foreground, thing that we're looking at, that's the guy that got the CPU. And the other stuff in the back, while they were technically alive, they were loaded into memory, they weren't getting CPU time. That way we were feeling like it was all working?
Yeah.
Something along those lines? Okay, does that mean, I mean, so when you use your computer now, do you only ever actually, as a human being, do you only ever actually do one task at a time? Or do you sometimes have maybe something downloading in the background while you're working on something? Or have some music playing in the background while something else is downloading in the background while you're working on something? You know, we can keep going down the list, right? Come up with examples of, we might have one application that we're technically directly interfacing with right now, but we might have other applications that we expect something out of that are happening in the background. This was actually something you saw in some early, probably most evident from a historical perspective in the Mac operating system prior to OS X, is it used something called preemptive multitasking. So what would happen is when you're, let's say you started downloading a file in the background. Now keep in mind, this was during a time period where our internet connections weren't all that fast. Okay, so you might be downloading, you know, not that big of a file, maybe a, you know, a 10 megabyte file. And, you know, back then Linux was, it seemed like Linux had more popularity as like the geek operating system. Now it's almost just accepted as like some people use Linux. Clearly not as many as Windows and the Mac OS, but you know, so a Linux download might have been 600 megabytes, you know, an ISO that you would burn to a CD or something like that. And 600 megabytes over a dial-up modem was going to take a couple minutes, right? So that might have been a 4 or 5 hour download or more. You know, well, we can do the math. So if it's 600 megabytes and we are on a 56 kilobit per second connection, so and let's just assume we're getting maximum speed out of our connection, which you likely probably were not. So 56 kilobit per second is 7K per second download, 7 kilobytes, or 0.0068 megabytes per second. So 0068. So we times that by 600. Let's see. Yeah. So we're going to say 600 divided by this guy. And that's our number of seconds. Okay, divided by that, that's our number of minutes. Okay, divided by that, that's our number of hours. Okay, so you know, I might be dating it a little bit. Maybe we weren't downloading 600 megabyte things, but based on this, it was going to take a day. All right, if we were downloading something that large back then. Now, the idea would be if you started downloading it and you went to sleep, first of all, you wouldn't be able to rely on your cable or your dial-up modem to stay connected that long, right? You know, there's a lot of interference on telephone lines and stuff, so some of you would just disconnect sometimes. And you probably were not also getting maximum speed out of this thing. And keep in mind, the 56K modem was once things felt fast, right? That was when things were fast. How long would 600 megabytes take to download today? You know, if we do a speed test on today's network, I'll leave that up. So let's just see what I'm getting right now on, oh, that's actually not that great. Oh, it's getting better. All right, wait, we started looking okay there at the end. All right, we're just going to say 100 megabits per second, right? Which is pretty good. It's reasonable, right? So that's kind of like what you could expect as a maximum speed from your home internet type thing. So if we
But
were getting it, go ahead.
yeah, if we are having 100 Mbps, I think we will be only able to see like 12 or 15 Mbps per second while downloading.
Yeah, so it's 100 divided by 8. So maximum is 12.5 megabytes per second. Possible capability if you're getting your maximum speed, right? So if we take 600, we divide it by that, now we're at 48 seconds, right? So less than a minute to download that same file that over a 56K modem a couple of minutes ago was going to take us a day. So things have improved quite a bit, right? And this is on kind of a budget pleaser internet, 100 megabits per second. If you're on DSL, you're actually only going to get about maximum speed of 24 megabits per second, just because of the technology of DSL. Things are moving towards fiber over on the telephone side of things. DSL technology still uses the plain old telephone service, POTS network that dial-up modems used. It just doesn't use analog across it. It uses a digital signal over the copper. So you are more limited on maximum speed. That's why if you go shopping for internet and you're looking at buying from like AT&T or Verizon versus Spectrum, let's say in this area. So we'll just use Grafton as an example. If I'm buying internet in Grafton, I can probably pay less and get 24, actually I doubt I can get 24 in Grafton. I probably get 18 megabits per second DSL in Grafton. That speed difference is how close you are to the telephone, what's called the D-SLAM. So they chain D-SLAMs together to try to get you the best speed, but really 24 megabits per second, you kind of live in like an office at the telephone company. You're right there, attached to them. But 18 megabits per second is probably within the realm of possible in Grafton. Maybe they'd sell you 24 and you'd get 21, something like that, whatever it is. And it's probably, if you bundle it with TV and stuff, it's probably half the price of Spectrum is my guess. I'm making up those numbers, but it would be less expensive. But the budget pleaser version of Spectrum is 200 megabits per second. So, at least 10 times the speed. Okay. But keep in mind that that's not because Spectrum's just better and AT&T is, not selling as much bandwidth. It's the technology they're using to deliver that bandwidth, right? If you were down in Milwaukee, a couple of you live in Milwaukee, right? What kind of internet do we have in Milwaukee? You have Spectrum? Okay, what's your speed? 200 probably?
Yeah, maybe.
You have the lowest level, whatever's the cheapest?
Yeah, the student privilege club membership, it is $60.
Okay.
And around like 200 with unlimited downloading and stuff like that.
Gotcha. So you're probably getting 200 megabits per second. If you pay a little bit more, that's probably more than a little bit more. It's probably 30% more. You can get 400 megabits per second from them. Anybody live in Milwaukee have AT&T?
I have.
You have AT&T? What speed do you have with AT&T?
I didn't test it.
Oh, you haven't tested it?
No,
What did you pay for? Aren't you paying the bill?
no. I'm living as a paying guest, so they are paying. Owners are paying me.
Oh, so it doesn't matter. Somebody else is paying the bill.
Yeah.
The speed is what the speed is. So one thing I'll tell you is, as a technologist, you should always know about the technology you're using. Now, it's acceptable if I call my mom up and I say, "Mom, how fast is your internet?" And she says, "Oh, I can just check my email and it's good," right? That's okay if my mom says that. Now, but we're grad students in a computer science program, right? We should know about the type of technology we're dealing with. That makes sense? So the reason I brought up Milwaukee, and I know we're getting a little bit into network stuff, but that's okay, because I mean, when we're talking about mobile computer architecture, we really are talking about how do these mobile devices that are in our pockets all the time talk to the rest of the world? Because no longer does our computing just exist inside of our computer, right? We leverage, I mean, right now, half this class, more than half this class, I've had my audience trickling in this morning. We had what was it, 10, 12 minutes late over here. Then what, 20, 25 minutes late, and you didn't even bring me coffee? Yeah. This does not bode well for grades, is what I'm saying. Historically, our grad classes used to be in the evening, like 6 to 10 p.m., something like that. But, I don't want to come in the evening. So class starts when I start, is what it is. But also because the face-to-face classes are typically for our international students who probably have nothing better to do at 7:40 in the morning, right? Okay, so I've really done you a favor by starting at 8.
Yeah.
'Cause I was in my office at 6:45.
Trust me, I didn't find a car for about an hour.
You-
I was up since 6:30, no cars available in Grafton and Cedar for about an hour.
What do you mean, like for Uber?
Yeah. Uber and Lyft, both of them, no cars for about an hour.
So you had to wait for an hour to get an Uber or Lyft to get from Grafton to here?
Yeah,
Well, where do you live in Grafton?
I live in Cedar.
Oh, because you know your professor lives that way.
Yeah, I know.
So I could pick you up on the way to class and save you a couple bucks. Maybe I'll get coffee from him. Believe. No. Let me know. I can pick you up on the way over. I'm just listening to my audiobook on the way over, so I have to swing through Cedarburg. It's not the end of the world. Then you just have to pay for the return trip on Uber. Well, unless you're going home at the same time I'm going home. I got room. I got a big SUV. All right, but so anyways, if you're down in Milwaukee and you're buying from AT&T, so the reason I'm framing it like this is AT&T doesn't equal bad internet, because in the if I lived in Milwaukee, I would actually buy my internet from AT&T, because in Milwaukee AT&T has fiber, so you can get gigabit internet in Milwaukee for less than you're probably paying for your 200 megabit per second spectrum, or it's not that much more. So, but they've used a new technology. They're delivering fiber to the house instead of using these telephone lines that have been around for forever. I mean, if you have new construction today, a new house, I actually wonder if you buy a brand new house today, do they still put telephone lines in that house? I feel
Not
like they probably still would. They're running other wires through the house anyways, and what's the worst that happens? You don't use it? But I don't know. That's an interesting question.
Are we talking here or globally?
Well, I'll just say here.
Um,
Yeah, brand new construction here. You're buying a new house.
I don't
I'm picking the color of the cabinets. They're building it as soon as the weather turns. I wonder if they put telephone lines in that house, or if they, they would do whatever you want them to do. I wonder what the default is. Kind of an interesting, unimportant question, but just interesting nonetheless. But anyways,
Professor Lippman, this is Janet. We just built our house and moved in August. They did install telephone lines. I have 4 telephone jacks throughout the house. Nothing's plugged into them, but they're
right.
there.
Yeah. Okay. So, and you didn't have the option. That's not like something you asked for, right?
No,
They just came
no,
up.
I didn't ask for it.
Now, the good news is there are some interesting technologies you can use to take advantage of your telephone lines in your house. Like you could have kind of shared Ethernet between, rooms and stuff like that. There's some technologies that'll use your internal. It's at this point, it's not as good as Wi-Fi probably, but there are some uses for those wired telephone ports. But yeah, same thing for us. Even years ago, we had Vonage was one of the early guys for voice over IP. So we were using our internet connection for telephone. And now you have people who don't even get home-based internet. They just use their hotspot, right? Because a lot of the hotspots have unlimited internet, and there's many cases, and this is kind of an interesting thing. The other day, I saw some commercial that talked about that, I don't remember what it said. I think it was for cell phones, something like speed as fast as Wi-Fi. But that doesn't mean anything. Fast as Wi-Fi doesn't mean anything. If I go into McDonald's and I'm using their Wi-Fi, it's going to be slower Wi-Fi than I probably have at my house, right? Now, they might use the same technology to deliver that Wi-Fi, but the Wi-Fi is only as fast as the bandwidth that's driving it, right? Okay, so yeah, just kind of an interesting thing. And that's kind of what I'm getting at here with, as technologists, we're also consumers. Now, if my mom gets taken advantage of because she bought the, thing that's as fast as Wi-Fi, that's more acceptable, right? If we get taken advantage of, it's because we didn't learn the stuff we should know as technology experts. Make sense? All right, so we should know about the stuff that we're using, Ishtiak, even if you're not paying for it. That's your new rule moving forward. Whenever you adopt a new technology, you want to understand what's going on with it. Okay. So in any case, let's jump back here.
I have a question here.
Sure, go ahead.
The background applications and background services are does they fall in the same category when we consider single core and multi-core?
Yeah, so we're back to this. So we said sometimes you might want to do more than one thing at once. So that's where having multiple cores makes sense. But then to answer your question, we would say not all tasks are created equally, right? Some tasks might require some additional horsepower. I have a buddy who, doesn't do any off-road driving or anything like that, has this super expensive car with I don't know, a V. Yeah, it was one of your jobs to wave your arms, right? Was that Galib's job?
It was Galib's job.
You're supposed to wave your arms so the lights don't go off. And this is actually very related to what we're talking about. They're just trying to save electricity. We don't move enough in here. Must not be anybody in the room. So shut the lights off. We're using one of those efficiency cores. So in any case, not all tasks are created equally. If we're playing like a video game, well, I was telling the thing with like my buddy, he has this super, he just does highway driving, but his idea is, oh, I need to have this gigantic engine. When he was buying his car, he got like the upgraded to the upgraded to the upgraded engine or something for, I don't know, $20,000 more. It's so like, oh, when you're getting onto the interstate or you need to pass a car on the interstate, you got the oomph to get by him. No, I mean, I can kind of get that idea. And the same thing goes for like the Teslas, right? They have the instant torque because it's electric motor. And then you get the one that's got the ludicrous setting, where you just hit the gas and you go from like 0 to 90 in like a second. And you get thrown back in the seat. And like it's cool for 5 seconds and you just realize that's really dangerous, right? You don't need, I drive a big SUV, but I'm also a big human. My wife drives this little Honda Fit and I take it in for oil changes. So first of all, it's kind of funny to watch me get in and out of that. But I promise you, when I'm getting on the interstate, this little 4-cylinder car carrying effectively a bear can go fast enough to pass people and to get on the interstate. It all kind of works out. All right, so but in any case, not all tasks are created equal, and we want to be able to utilize our processors in such a way that we are always happy as an end user, right? Because we're greedy. Humans are greedy. We want unlimited battery life. We want everything to feel instantaneous. We want perfect screens. We want to be able to turn the brightness up and not have our battery die on it. I like when students come to my office and they have their brightness turned down to like 0.2. Like what kind of like cat's eyes? I have to look like 4 times before I realize the monitor's even on. It's like, yeah, the battery doesn't work this thing. So I try to use my laptop basically without a screen. But not all tasks are created equal. So as a human being, we want to be happy, but we want to have those trade-offs in times where we're maybe not going to notice. And that's the idea of having these multiple cores. Multiple cores have existed in desktop processors for a while, right? And they've existed in mobile devices for a while as well. But the initial push into our mobile devices kind of had the cadence of duplicating what the desktop processors did. So you might have 4 cores or 2 cores or 6 cores, whatever it was, but they were all running at the same speed. Now, when we're plugged into the wall, fine, your electric bill's a little higher, which may or may not have its own problems, right? That doesn't mean we should just be completely oblivious to how much our, people do buy too much computer for their home computers too. They think, oh, I'm going to drop $4,000 and get, 32 gigs of RAM, and I'm going to get a 8-core Xeon or 8-core i9 processor or whatever it is, and all they use it for is like web browsing, something like that. Again, if my mom did that, I'd yell at her for spending too much money on the computer. If any of us do it, then that means we don't understand the technology of getting the right tool for the job. All right. I mean, you got $3,000 or $4,000 laying around. You want to get as much out of that money as you possibly can. And if you need a computer for a certain task, don't just buy the most expensive computer. You might not notice a difference, right? In fact, in many cases, you wouldn't notice a difference. But certainly that decision making needs to change. But in the early days, how many of you have been iPhone users for at least 9 years? I know we're going back pretty far at that point, but I think 9 years will get us to where my example is. Yeah. Yeah. Anybody been an iPhone user that long? So let's do early iOS. What has changed? Anybody know the kind of the major things that have changed since early iOS? How many of you on your smartphone might have the music playing, but you're also flipping through and you're checking your email or your web browsing or something? It's a common task, right? You got something going on in the background. Now it's pretty common. You could have like a YouTube video playing, and then it just goes down to the corner while you're doing some other stuff, whatever. So in the early days of iOS, there was no multitasking. And this was true even after they added a second core to the CPU. Now, I'm really saying no user level multitasking. Because realistically, the operating system has to be running in the background while the user applications are running, but the user could have a single application running at once, which means that if you wanted to listen to your Pandora, you couldn't be checking your email, right? If you went to email, Pandora was in the background and it would stop playing music. Why did they do this?
Maybe so that if one application is loading, it works with 100% efficiency, and if multiple in the old iOS, if two applications work at a time, so both will take code from the processor, and it will take more memory, so that's right.
Okay. Memory probably has not been our problem for a long time. In general, when you go out and you buy a new smartphone, there isn't a difference in the amount of memory between the flagship versions of a phone, right? What's different is the storage. How much, how many movies or how much music how many pictures can you store on this thing at one time? That's what you really pay for. Every now and then at the very, 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 very top level, they might have one that's more geared towards gaming, or maybe it does have a little bit more memory, but in general, that's not a dividing thing for us. Now we roll back 11 years, memory was still pretty inexpensive 11 years ago. So even though the smartphones back then did have less memory in them than they had today, it probably wasn't a driving force in terms of resource management. The real problem was,
battery issues.
say this again?
Battery issues.
Oh, battery issues. Yep. So multitasking models back then were based on a computer tethered to a power outlet. So they were, you know, they were great multitasking models. Nothing wrong with them. They just assumed you had unlimited electricity instead of a battery that was draining constantly, right? So when something went into the background, it was getting CPU time. And it was using, you know, it was the CPU was running. Back then, we probably didn't have different speed cores, so everything was the high performance core relative to it. Certainly, it was going to be, you know, using other system resources like memory and stuff like that. So Apple made the decision not to support multitasking. Not so much that the end user wouldn't have enjoyed multitasking, but the end user would rather be able to use one task at a time and have the battery last all day than be able to do more than one task at a time and have the battery die in 5 minutes. So if we also go back to early Android, did early Android have multitasking? Anybody been using Android for 9, 10 years?
Been using since Gingerbread.
Okay, well,
Android.
what year was Gingerbread? 2015?
Maybe, probably, yeah.
Okay,
Not 2015. I think 2013.
okay. Well, so early Android, do you think it had multitasking or not? Yep, this guy did support multitasking. I'm going to say this was based on the Linux OS. What did people complain about?
Using another app to kill the apps.
Yeah, so that was the next question I was going to ask. So what did people complain about in early Android? Bad battery life, right? In fact, most popular app for a long time was an app to kill other apps. It made it, because you could do it. You could go into like preferences and get in, you know, dig down 3 or 4 levels and be able to kill off applications that were running in the background. But one of the most popular apps in the beginning, actually it was the most popular app, was apps to that showed you the list of running applications that allowed you to conveniently kill them off so they stopped using your battery in the background. Okay, and we're not just talking about the, you know, the app that you just put in the background a second ago that's playing your music. We're talking about the app you opened 4 days ago and used it, you know, like some bank app or something like that 4 days ago and forgot you had ever opened it. And it's still sitting there using up battery life in the background, just cooking, right? All right, so early Android suffered from that. Keep in mind that the very earliest of all these didn't even have app stores, right? iPhone, the very first version of iOS, there was not an app store. That came out year 2.5 or so was the app store. They announced the app store at the same time as they came out with the iPhone 3G. Yeah, so most popular for a long time was an app to kill other apps, had bad battery life. What did people brag about?
Keyboard.
We're going to say in error with Android. I don't know. I think the iPhone keyboard has always been at least as good as the Android keyboard. Well, we're about to talk about that. Yeah. Maybe you're talking about the swipe keyboard. People like that swipe keyboard for typing on there. Android had the swipe keyboard way before iPhone did. But what did people brag about? Typically, they bragged about multitasking.
Number of applications in the Play Store. Oh,
Well,
okay.
keep in mind the Play Store wasn't even available yet.
Yeah, early Android. Yeah.
Okay, so they bragged about multitasking. They also bragged about Flash support. Those two things, because back then a lot of websites had Flash technology on them. You know, you went to Yahoo Games and, you know, poker or whatever was all written in Flash. So, so something I always, and Apple did not have flash support. Let me go back to this previous thing. Oop. No flash support. Insisted on HTML5. So Apple's probably the one that got HTML5 over the finish line and made it kind of the industry standard now. Now,
And
where
iOS was supposed to use iTunes at the time.
well, what do you mean use iTunes?
I mean, to connect to the PC or Mac. So they are supposed to use iTunes to copy files and all.
Okay, yeah. So the way you would like load your music and stuff like that onto the iPhone initially was the same way you would do it for an iPod. Hook it into iTunes, and you'd be able to do software updates that way too, and all that stuff. All right, so no flash support. Assisted on HTML5. So then, how many of you are Android users in here? We got 2 in the classroom here. What about online? So it's a 50-50 shot whether this is poor voter turnout or everybody online is an iPhone user. Okay, but usually you get about half and half, right? So how many of you Android users appreciate the flash support on your device? You never care about flash support? What about you?
Actually, I didn't know about Flash at the time when I was using Android.
Okay, you didn't know about flash, okay? Plenty of websites had flash support back, had flash on them back then. So what would happen if you visited one of those websites on a iPhone or an iPad?
I think we use sort of edit on the top of the
Yeah, parts of this page can't be displayed, something like that, right? But if you visited those pages on an Android device, what would happen? Okay, so he said they would work normally, but were they really working normally? Or was the end user experience still bad? Those flash things, they didn't look right on a mobile device, right? Technically, they might have been running, okay, but they didn't look right. So from an end user experience perspective, let's ask the first part. Based on the usability of the flash applications, was it worth it? Was it worth having flash on there? Was it something to really brag about? As bad as they actually ran in the browser?
I think it only makes the website slower.
Okay, probably it makes the website slower anyways, but if you're on a desktop computer, then maybe not the end of the world.
I think at this time, maybe it could have been a braggable point because of multitasking that gave the mobile user, but from the web user experience and training battery life, it took that.
Okay,
At that point in time, this was the only, Android is the only OS that can provide multitasking. So that's why I think that
but we're talking specifically flash.
yeah, I'm talking specifically.
Okay, so what does flash have to do with multitasking in your example?
No. I mean, sorry. I mean, okay, then valuable point because the usability browser changes, like it can play flash.
Okay,
I think at that time, flash was popular online. As mentioned,
sure. So if you happen, I mean, realistically, you probably were not playing any flash-based game on your mobile devices. It didn't work well enough for that. Every now and then you might have gone to a website that maybe had like sports scores or something like that that were based on Flash. I don't know how common that really would have been, but possibly, some kind of widget that gave you some information that was Flash based. And maybe it was good enough that it would have been adequate on the Android browser. Okay. Now, if we pause mobile phones for a second, just to see how bad this idea was, they just recently got rid of a discontinued Flash, right? Adobe just recently, in the last like year, they finally discontinued Flash even on desktop. So if you had a laptop, which presumably has a lot bigger battery than a cell phone, right? And you went to, so let's say you had a laptop that when just working on Microsoft Word or something like that, or watching a movie, gave you 4 hours of battery life back then. Use that as our number. Let's say you took that same laptop and you just went to Yahoo Games website and you were playing solitaire using Flash. What was your battery life? Yeah, gives you 4 hours when watching a movie or 4 hours when using Microsoft Word. But now you're on Yahoo Games website playing a Flash-based game like solitaire. That same laptop, how much battery life do you think you'll get on that laptop?
Probably the same.
You think in 4 hours?
10%
10% less? Anybody else have an opinion? 20% less. Yeah, both of those numbers probably would have been somewhat acceptable, right? Yeah, I bet you probably would have gotten about 20 minutes of battery life. Not 20% less, about 20 minutes. Yeah, maximum. Flash was very, very, very processor intensive. It used a lot of system resources to do what it did. Now, for a computer that's tethered to the wall, not the end of the world, okay? But the mobile version of Flash was never friendly to batteries. Whether it was a cell phone or a laptop, it was never friendly to batteries. All right, so this was a problem right from the get-go. The second we start thinking about mobile technology, batteries become an important part of the conversation, right? So when we're talking about early Android, many of the decisions that early Android had were directly detrimental to the battery. Where you might have a phone that can do some stuff that you found helpful, but it could only do them for a half hour. And then your battery was dead because of the nature of it. Why do you think Android made these decisions? What drove them to that? Which came first, iOS or Android?
iOS.
iOS came first. So Apple had iOS, and in the very early days, I mean, did smartphones exist before iPhone? Yeah, like a smartphone-esque type devices. We had the Palm Trio. Palm Trio was a popular smartphone device. What were those devices running? What operating system was the smart devices running back then?
Symbian? I don't know.
Okay, yeah, Symbian was one of them. Palm OS, maybe another one. Windows CE was Windows kind of mobile version. And I would say most of the most popular devices back then were probably running Windows CE. Now they were different. Oh, also BlackBerry OS, right? Okay, BlackBerry was a big deal, because with BlackBerry, everything was about the physical keyboard. You had the actual buttons to click, and people liked the physical keyboard. Okay, but you were limited on what you could kind of do on the device. But for business users, you could do what you needed to do, email and that kind of stuff. What did iPhone bring to the table? What was the kind of the iPhone's claim to fame, if you will, that it brought to the table for mobile devices?
Touch support.
Say this again.
Touch support.
Tech support?
Touch.
Oh, touch support. Okay, so multi-touch. So certainly that was, now before that we sort of had, it was really multi-touch that it brought, right? Before that you had like most of the devices had like a stylus, right? Where you click on the screen, it was all pressure based. So you could hit something with your thumb back then if you wanted to, but this whole idea of the multi-touch with gestures and things like that, that was kind of a big deal. All right, what else? Kind of related to that. So we might say that from a gesture perspective, the biggest gesture was the swiping for scrolling, right? Okay, that swiping for scrolling allowed what to be a much better user experience? What was important to people, 12 years ago or whatever, whatever year the iPhone came out? That didn't really work very well before that.
It was having a slide support, like not sliding upwards, rather it's from left to right or right to left.
Yep. So we just said that. So scrolling up. So, but what did that give us the ability to do that wasn't a good end user experience before that?
User interface.
Okay. Tell me more about that. Well, what about the user interface?
More optimized UI.
Icon system.
Okay, when we say more optimized, what does more optimized mean? What, at the end of the day, from an end user experience, what does optimized mean to us?
User friendly.
Anywhere you can on the screen.
Fixed icon system.
Okay, so first of all, you had bigger screen, right? Because they had the software keyboard that would slide away. So you had pretty much twice the size of the screen minimum than you would have on most other devices. Okay, so much bigger screen. They probably, the user interface, we're talking about kind of a similar jump as maybe going from Windows 3.1 to Windows 95, where we had like a huge jump forward in what a mobile specific interface looks like. Because before that, if you looked at Windows CE, you still had the start button, right? Windows CE was just a kind of a pared down version of, Windows 95, Windows 98, a normal Windows desktop environment. And it wasn't a joy to use in mobile. Many times you would use it mobilely when you didn't have access to your computer. Probably scheduling and email were maybe the two go-to moves for it. Okay. With iPhone, were there any new tasks that were much easier to do on that smartphone than before, that we kind of take for granted today? Did people use their smartphones for web browsing before iPhone? It technically existed, right? Yeah. But I mean, you maybe would use it to find out like what time a restaurant opened, or start times for movies or something. Just something that did not require like a heavy amount of user interface use, because typically the web browsers were pretty small because you only had that like half-size screen because you had the physical keyboard. And the mobile web browsers did not give you a full desktop web browser experience. A lot of them wouldn't load the images, or if they did, the images would load very, very slowly. And sometimes they'd pop up and the thing would scroll on you. And it just wasn't a good end user experience. If you had to look something up and you just needed the information right now, you could decide to invest 5 minutes of your life to probably get it, right? So where iPhone made the idea of web browsing on a mobile device real, where a lot of us now, we digest the internet probably more so through our mobile devices than we do on a desktop, right? Or even your laptop. I mean, we go to a desktop or a laptop and we're going to have like a prolonged period of time where we're reading something or doing some research where you want to have a bunch of tabs open and stuff like that. But even with that in mind, it's not substantially more usable than it is on your smartphone. In fact, there's probably some cases where the mobile version of a website's even better than the desktop version, and you prefer to use it on your smartphone. That's certainly true with some apps, right? There are some mobile apps that run natively on your devices now that you might just say, look, this is better than doing it on my computer. So even if I'm sitting at my computer, I might use the mobile app to do to do something. So these were all reality type situations. So with all that in mind, iPhone brought a lot to the table in terms of a new user interface and things like that. When iOS was first released, Apple built iOS from the ground up with a focus on mobile computing. That's why they made some of those decisions about no multitasking, things like that. They wanted the end user experience to be good, even if things that people had become accustomed to using their computers for weren't things that were going to be available right off the bat. But other things that people had been accustomed to using their computer for, and specifically not reliant on their mobile device for, could now be done. Okay? And that's why iPhone was so popular, even though it was perceived to be very expensive, and what does Apple know about phones and all that stuff, right? You know, it was a risky endeavor for Apple to kind of pull this off. Now, that all being said, why did Android make the alternative decision to support Flash, to support multitasking? Why did they do that? Okay, so related to competition?
Evolution in the desktop industry, like multi-core and all.
Make some of these bad decisions. So iOS was already out. It was already very successful. And Google, makers of Android, needed to try to compete. What is the fastest way to get a competitor to market? Okay, so I mean, you could just do the opposite of whatever they're doing, right? That was Microsoft's approach for years. You know, Apple adopted FireWire, Microsoft went USB. Apple adopted, Microsoft adopted C++, Apple went Objective-C, so on and so forth. But really, with Android, they were dealing with time, right? They needed to compete directly with Apple. It was actually kind of an interesting time, because during this time period, Android, Google and Apple were considered friends, where Microsoft was kind of the enemy during this period of time. Google had several members of Apple on their board. Apple had several members from Google on their board. So you imagine some of the decisions that had to be made by the board, people had to recuse themselves, leave the room, so that they could discuss something that maybe the other guy, not necessarily an enemy, but the competitor, maybe shouldn't be involved in talking about. Okay, so what's the fastest way to get a competitor to market? Use an existing OS like Linux and port to mobile. What did this come with? This came with the features of Linux, like Flash support, desktop class multitasking, etc. Everything good on paper. These features did not consider battery life at all, because they were built for a desktop operating system, Linux. Android was in a rush to get to market, and rather than build an OS from the ground up, which would have taken time, they got an OS onto devices that was, by all intents and purposes, a quality operating system as far as operating systems go, but not necessarily the right kind of operating system for mobile devices. Hence the complaints about bad battery life. Fragmentation was another complaint. When we say fragmentation, why did people complain about fragmentation when it came to Android devices? First of all, what does it mean? Huh? What does it mean to say that the Android ecosystem was fragmented? And really, this question could be rephrased and say, how was Apple? Khalib, wave the arms. Oh, you lost it. So how was, oh, there we go. How was Apple different from other tech companies? And really, how do they continue to be different? So what do they mean when they said that Android was a fragmented ecosystem?
I think I have one point.
Say that one more time.
I think Google has like it can release security patches for only 2 years for a device, and after that it will. I mean, not security patches, OS updates. So for iOS, it's different. It gives the OS updates until the device updates.
Okay. So when we talk about security devices, I mean, security patches, I think maybe what you're kind of alluding to is the idea not all devices got the security updates at the same time, right? In fact, when you go and do Android development today, you have to choose what your target Android operating system is, and it tells you roughly the number of devices that that would likely run on if you use the features from that. Because typically every new version of Android is a superset of the previous version. It knows how to do all the magic tricks of the last guy, and then some new stuff, right? Well, if you're writing an application for Android and you're targeting, some feature that was added to the latest, greatest version of Android, chances are that your application is only going to run on like 1% of the devices, or even less than 1% of the devices, because only the people who have the latest, greatest flagship smartphone, and even then, even if you have that, unless it's a Google phone, a Pixel, you might not have the latest, greatest version. You might be one version older, something like that. So typically, as an Android developer, you're going to pick your platform that you're targeting to be some, maybe it's API 16 or 17. Lollipop is the version that's hitting my mind right now, that basically says this will cover like 100% of devices. If somebody's running Android, they're running at least that version of Android, more than likely, something like that. All right, so first of all, Android did not, this is all part of the same problem. Android was made by Google. Who made the smartphones? All sorts of companies, right? Just like the Microsoft problem. So Google was solving the old Microsoft problem. That is, write an OS for other people's hardware. Apple was still solving the Apple problem. that is write an OS for only our hardware. No wonder it tends to work a little better, right? The first iPhone, the first iOS just had to run on the first iPhone, one device. Now, even after they started coming out with newer versions of iPhone, so you had, the first iPhone, and you had the iPhone 3G, and then you had the iPhone 3GS, which was just a faster version of the iPhone 3G. Then you had the iPhone 4. What did the iPhone 4 bring to the table that the iPhone 3GS didn't have?
Square shaped phone.
Um,
I mean rectangle. I mean soft corners without a
Okay.
curved.
it was a physical redesign, right? Remember, the antenna went around it. It was like a metal band that went around it. Then they released the bumpers for that because people were blocking the cell phone signal with their hands, that type of thing. But the screen size was still the same size with iPhone 4. Actually, I'm lying. Well, yes, it was. Screen size was still the same, but they introduced the Retina display, a higher resolution display. In fact, it was exactly double the resolution, which means anybody who was writing applications could just design for the Retina display on the iPhone 4. And then if you were running that on an iPhone 3GS or 3G or original iPhone, it would just have it, and the scale would still look good. The image would still look good. iPhone 4S, just a faster version of the iPhone 4, still with the Retina display. iPhone 5 introduced a little bit taller display. This was Apple's first entryway into fragmentation, right? So you're at iPhone, 3G, 3GS, 4, 4S. You're 5 years in to the iPhone ecosystem before they deviate from a standardized screen size. So when you were writing applications, all of those applications were designed for the same physical screen size. So it's not surprising that those applications felt more polished. That makes sense? All right, so homework. We're almost to assembly language. Write a 2-page paper comparing and contrasting iOS versus Android over the years. Make sense? All right, questions, comments, concerns, bribes. All right, I will see everybody on Wednesday morning.